So let's start. So when I look at these problems, one of the things I want to do is make sure I talk about the most common errors I see. So when I look at this problem, here's a big persistent error. Oftentimes people will see this x to the negative fourth and x to the fourth and just say, oh, those are the same, right? And what I see people do is they'll just cross this out as that's a giant one. These are not the same. These would be the same if they were both x to the positive fourth, but they're not. One way to think about this is if I'm looking at just the numerator, in fact, let me cover up the denominator. If I'm looking at just the numerator, what is this? This is 49, and then because this is a negative exponent, it's 49 divided by an x, divided by an x, divided by an x, divided by an x, right? This is 49 divided by x 4 times. And if I don't like looking at negative exponents, I can say, you know what? I'm not going to do that. I'm going to go ahead and multiply that times 4x's. So look at this. If I start with 49, I divide by x 4 times, and then I multiply by x 4 times, I'm back at 49, right? These two together equal what number? They equal the number 1, right? So dividing by x 4 times, multiplying by x 4 times puts me back at just 49. So this becomes the number 49. Now, I got a problem. I can't decide that I'm just going to multiply the top only of a fraction. This is not an equation, it's just a fraction. I can't multiply only the top by x to the fourth. I have to do the same thing in the bottom to make this a giant 1. Now, when I do this, my numerator has no factors of x, right? It's x to the 0. So all the numerator is just the number 49. There's no x there at all. The denominator has how many factors of x? 8, right? 4 and 4 more. So I've got 35 and x to the 8th. The other common error I see is I see people do this as a subtraction problem, and they'll write this as 14x to the 8th. Hey, this is a division problem. It's something divided by something. There's a common factor. What's the common factor we have here? Yeah, so I can write this as 7 times 7 over 7 times 5. They both have a factor of 7. I've got 8x to the 8th in the bottom. This is gone, so my final answer is I've got a 7 in the numerator, and I've got 5x to the 8th in the denominator. These will be slightly different than the order your paper is, but it'll be pretty easy to jump around. The next one we're looking at is this. And here's an error I see. Sometimes people will look at this and they'll decide that this is 4 to the 5th power. Hey guys, look at this closely. The only thing that's getting raised to the 5th power is the x, right? There's no parentheses around the 4x. So this is just x, 5 factors of x times a 4. Now, this is squaring this. That means I've got 2 copies of this. And if I want to square it, I could just write it this way. Hey, there's a 3x cubed times another 3x cubed times this 4x to the 5th. When I look at this, I can say, hey, there's 3 factors of x and 3 more factors of x. How many factors of x do I have right here? There's a total, there's 6 there, right? There's 6. 1, 2, 3, 4, 5, 6. So I'm going to write this part down. This is x to the 6th. And then I've got 2 factors of 3. Factors are multiplied to produce a product. If I have 2 factors of 3, what number do I write down? 9, right? So you can also look at it like this. This is 3 to the 1st to the 2nd, which makes 3 squared. And this is 3 to the 3rd to the 2nd, which is, x to the 3rd to the 2nd, which is x to the 6th, right? So I've also got this part. Now, there's a number 6 and a number 5, but those aren't numbers. They're just telling me how many factors of x I have, right? How many factors of x do I have in my full product? There's 11 of them, right? This is going to be x to the 11th. There's 6 x's being multiplied times 5 more of them. And then what's the number I put in front of that? 36, not 13. 4 times 9 is 13. So this is 36 times x to the 11th power. Next. Hey guys, what's the thing that I can multiply everything by to bust up these fractions? Yeah, 2x. And I like how you said 2x over 1 because it's convenient to write it that way, right? 2x over 1. If I was multiplying it by 2x over 2x, I would just be multiplying it by 1 and it wouldn't change it, anything. But if I'm multiplying both sides by 2x, because it's two sides of an equation, I can do that. I can multiply this side by 2x and this side. There's 3 terms that need to be hit with 2x. There's 1 term on this side that need to be hit with 2x. Now, here's how I might write this so I'm really clear. I might write 7 times 2x over 2 minus 5 times 2x over x plus 15 times 2x over 2x equals 9 times 2x over 2. If we look, we can see that every single one of these terms, this term, this term, this term, and this term, that got multiplied by 2x times the 2x times the 2x times the 2x. What's convenient about multiplying by 2x is it clearly busts the fractions, right? If you look at these fractions, this is no longer a fraction. It's just a 1 in the denominator. No longer a fraction. No longer a fraction. And no longer a fraction. So because I've busted all the fractions, right, what do each of these terms become? Yep. Minus. Yep. Plus. And that equals 9x. So these together make a 5x. So I've got 7x plus 5x equals 9x. This is 5. Negative 10 and 15 is just positive 5. Therefore, 5 is 2x. Yes. Yes. So, good question. So, if you look at this previous problem right here, I definitely multiplied both the top and bottom by x to the 4th. And the reason why I had to do it here was because this was not an equation. This was just one single term. If I have an equation, I have more tools than just multiplying by the number 1. In the case of an equation, I can multiply both sides of the equation by the same number. A simple example of that would be if I have this equation, right? 3 plus 2 is 5. Roberts, that's not an equation. Look, it is. If I multiplied every single term by the number 2, what does that become? It becomes 6 plus 4 is 10. Is this true? Yes. Is this true? Yes. If I multiply both sides of an equation that has an x involved with it, it's going to get all the same solutions, right? This equality is preserved. So I can multiply this term, 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 and term all by 2x, and I'm not changing the nature of the equation. This was a bad example to show with just numbers. Let's look at this. If I said x plus 2 is 5, you guys all agree that x is 3, correct? Right, x is 3. If I multiply both sides of this by 3, I get 3x plus 6 is 15. We just said x was what number? 3? What is 9 plus 6? Notice both of these equations, the original one, x was 3, this one, x was 3. When I multiply every term by an equation by the same value, it doesn't change the answers to the equation. So when I'm looking at this, I have this powerful tool of being able to destroy or bust fractions by multiplying both sides, this side and this side, by 2x. And you guys, it has to be all the terms, right? I look at this and I see 1, 2, 3 terms on this side, 1 term on this side. All terms were multiplied by 2x. So there's one last thing I want to do here before we move on. Camille, can you go to the calculator? So you guys, we get 5 halves is x, right? we write this, but there's nothing about my number sense that tells me I'm right. So I'm going to have Camille quickly check this for us. And we're going to do that. Whoops. Do you see a calculator on your screen? You do? That's the calculator, huh? Is it going up and down? Is it just staying there? It's not moving? You didn't break anything. I'm just like, oh. Okay, there we go. Okay. So go ahead and enter 5 over 2. And the best thing, no, 5 over 2. I'm sorry. 5 over 2. You got it. 5 over 2. And then store that as x. Perfect. Enter. So she's taken 5x and put it into 5 over 2 and put it into x. Now we're just going to check this. So enter 7 over 2. And then leave the fraction. Yeah, up, sorry. You're okay. Hit delete or clear. Yeah, up. Okay, you're good. 7 over 2. Then hit over arrow. Minus 5 over x. Avery's the queen of this. And then plus 15 over 2x. She won a competition on Wednesday. She was the fastest at this. So when you press enter, notice what it says. So here's why this is significant, right? We just looked at everything on this side and we typed it in with x being 5/2. And when I did it, notice that it gave me 9/2, right? So that is the solution. It's verified because it makes both sides the same. Yes. Oh. Thank you. Be ready to come back, okay? You can step outside if you want to. Okay. Next question. Hey, no one in this class came up and talked to me, and I'm thinking that's not because you were all confident with this one. You're just shy, or maybe you are confident with this. You guys, when I see 1/9 and I see 3, what do you suspect the base that we're going to go to is? 3. Yeah, it's going to be a 3. It's going to be a 3. Now, take a look at this. Sometimes it's very helpful to say, hey, if I think it's going to be a 3, I'm going to write different powers of 3, like 3 to the first, 3 to the second, 3 to the third, and also the other way. This means I divided by a 3. This means I divided by 3 twice. This means I divided by 3 times. Hey, what is 3 to the 0 power? 1. What's this? What's this? What's this? What's this? 1 over 3. What's this? 1 over 9. Now, the reason why this is nice is because, do you see this right here? Right? What we're going to do is we're going to take this 1/9 and I'm rewriting it. Can you get that door? Notice when I write this down, this is 3 to the negative second. What I just wrote on my paper is exactly the same as what I have above it. There's no difference at all. Then I'm going to go ahead and continue and write to the x plus 4 power equals 3 to the 3x minus 1. So this business about being able to switch to a common base, right? In this case, 3, you have to be able to do this for these problems, right? I'm not going to give you a problem where it's not possible. You just have to look at the numbers and decide, okay, what base do I want to go to? Now, there's another part of this, though. You guys, earlier, when we looked at this problem right here, and we had x to the third and I squared that, right? When I had x to the third and I squared that, what did that part equal? X to the 6, right? What operation do I use here as a shortcut? Right? So if I have a power raised to a power, I multiply. So if I look at this, this is going to be 3 to the, I need to multiply. What do I get? Yes. Continue. No. I need to multiply this exponent times this exponent.
Wait, no, that's negative 2x minus 8.
Minus 8, right? So this, I'm raising this to this. So boom. On the other side, what do I have? 3 to the 3x minus 1. So look, right? The bases are the same. All we do is we set the exponents equal. 2x minus 8 has to be the same as 3x minus 1. Therefore, negative 8 has to be the same as 5x minus 1. Therefore, negative 7 is 5x. Avery, can you go type this on for us? So negative 7/5 is our value of x, right? And we're going to check that. And we do that by, as quickly as possible. Type the negative 7/5 and then store that value.
Now what did you write?
Negative 7/5.
Because you subtracted 1 on that side and you subtracted 8 on that side?
In my mind, I added 1 to both sides.
Yeah. Oh, never mind.
Hey, if I'm wrong, she's about to reveal it right here. So we now have what x is. So Avery, you don't need these parentheses. Just go ahead and enter 1/9. And then go ahead and leave the fraction and raise that to the power of x plus 4. Go up 1. Right there, yeah. To the power of x plus 4. And press enter and let's see what we get. We'd have to write that down because there's room to see it on the display. Go ahead and do the other side, which is 3 to the power of 3x minus 1. 3 to the power of 3x minus 1. And we get, okay. So the reason why we can be confident that we have the correct answer is because when we plug it in, it made both of these sides 0.003303, right? This is absolutely the answer. I want to think about this though. I added 1 to both sides and then I added 2x. Okay. Next. Hey guys. So someone second period who will remain nameless came up and said, Roberts, I got a shortcut. All of your fancy work made that hard. You just take away 1 from both sides and then you divide by 4. And I said, well, let's take your answer and plug it in. And he was shocked when it didn't make it become 7, right? So then he says, okay, so wait a minute, what did I do wrong? I said, well, look, this whole thing is locked inside of a square root. So I'm forced to ask myself, what number does this have to be? And you guys are quick at that. And if you're confused by that, just squaring that will give it to you. So this has to be 49. So this has to be 48. So x has to be 12, right? Now, when I put 12 here, 4 times 12 is 48. 48 plus 1 is 49. The square root of 49 is 7. I don't need to check it on my calculator. I'm sure it's x is 12. Okay? Don't make me scared. Don't make me more nervous. All right. I think we're down to our last 3 boxes. Okay. Guys, when I write the following and only the following, what am I finding? What did I just find? What is that? Yes.
That's how you find the slope.
Yeah, but what is that? The difference in y, right? That's my change in y, the difference in the y's. Yes, or the rise. Very good. Now, hey guys, what would be the matching run? What would I write down to get the matching run?
Negative 18 minus 21, which is minus negative 21, so I think plus 21.
Minus negative 21. So this gives me 1 over negative 18 plus 21, which is that 1/3? Okay, 1/3. Hey, guys, the directions say fine line. It doesn't say the format I require. So there's literally 3 choices you have. And I'll just show you how quick these are. You can write the following. Y minus 16 equals 1/3 times the quantity of x plus 18. That's an answer that's valid. Do you guys understand why I'm writing the plus 18? That makes it difficult? Then do what you're doing. Yes. Oh yeah. Yeah. I'll do that one next. The other one that you can write is you can write, hey, y minus 15 equals 1/3 times x plus 21. Huh? Plus 21. Yeah, guys, when we're dealing with point slope form, remember we're it's x minus our known x value. So it's x minus negative. Hey, those of you that are doing the bit about plugging in and then solving for b, look at this. If I distribute this 1/3, this becomes 1/3 x plus 7, correct? Right? And if I add 15 to both sides, right? Do you see what I just did? What is b? Right? Hey guys, this is a little bit I'll tell you what I like about this format best is it is nice to verify you have the correct answer, because you can type this in your calculator, and if you plug negative 18 in, it should give you that y is 16. And also you should check both. If you plug in negative 21, it's going to give you that y is 15, right? So I will take any of those answers though, right? This one, or this one. Next. Hey guys, if the lines are perpendicular, if it's perpendicular to this line, what's going to be the slope that I have to use? Say it again. Very good. So my slope is going to be 7/4. So I'm just going to write the answer. Y minus 20 equals 7/4 times the quantity of x minus 16. So that would be, you can leave it there, that's fine. I'm going to distribute the 7/4. That's going to be negative 16 about negative 4. It's going to be minus 28 and then plus 20 more. So, oh, and I forgot the x. So y is 7/4 x minus 8. And that will go through this point, 1620, and it'll make a right angle with this. Hey guys, how do I know it goes through the point 1620? I mean, I can see it's got the right slope because I know that's, how do I know it goes through this point? That's right. 16 divided by 4 is 4. 7 times 4 is 28, and 28 minus 8 is 20. So when I give it 16, it gives me back 20, right? All right, last two. Good one. Hey guys, a reminder about generic area models. When you write them down, we multiply to get areas. So if I want the area of this rectangle, I have to go length times width. But once I find the area of all the individual rectangles, I add those areas to combine them, right? So real quickly, guys, what's the area of this rectangle? Very good. 3x to the power of 3. What's the area of this rectangle? Good. This rectangle? This rectangle? This one? And this one. So you can see some of those can be combined. So this is the area written as the length times the width. You see this? This is the area, length times width equals, what's the area is the sum of the parts. Go ahead. You can
3x third plus 14x squared plus 7x minus 4.
Fabulous. Right. That's exactly right. Good job. Right. Last problem. So on our last test, I saw something I really hadn't encountered before. There was some way people thought that this definition equaled the number -1, and they were setting this equal to -1. Hey guys, this is the definition of a function. The function's name is g. Oh, am I glitching? Yes. It's okay. I have a backup plan. I just have to hit this button. There we go. Oh, excuse me. So basically, this is the input to this function, and it says you're going to go 4 times the input squared plus 2 times the input, and then minus 5 from that. So if I look at this, right, my input is -1, and I'll put it in both of these. Now, you guys, some of you multiplied and then you squared it. Please remember, order of operations, exponentiation, then multiplication. So this becomes 4 times what number? +1, so this is 4. And then this becomes 2 times -1, -2, and then -5. So what does this equal? Very good. And then the last one, you guys see it says, tell me what f of 3 times g of 0 is. Well, g of 0 is pretty straightforward. If I put 0 here and here, what does g give me? So part of this is going to be something times the number -5. But then what is f of 3? Well, if I put 3 in for f, what does this become? 8. So this is just 8 times 5, which is -40. All right, so that's it for that walkthrough.